How's it going, guys? So I want to go over a 10-part series in the basics of 3D and what the different parts are. So there's going to be 10 videos here. I want to begin with the fundamentals of 3D, and then I want to go over primitives, and then I want to touch on materials and shaders, and then I want to go over normals and what they are and why they're important. I want to talk about the project outliner, and these are things that are going to be pretty universal across the different software apps, Maya, Unreal Engine, Unity, Blender. I want to talk about basic object manipulation on objects. UVs, what they are, what unwrapping is, what textile density is. I want to spend some time on what the 3D cursor is and how powerful that can be. Object modifiers and the different categories that are in them, and the different incredible potential object modifiers have in 3D. And finally, I want to touch on some basic animation skills. Alright? Alright guys, so I want to go over the fundamentals, if I can speak, of 3D. Exploring the basics, tools, and career paths in three-dimensional artistry. I wanted to go through this step by step, but I'll add extra notes and tidbits as I see fit here as we go. Understanding 3D representation. 3D, or three-dimensional representation, encompasses objects that possess depth, width, and height, creating a realistic visual experience. This representation is essential across various sectors, including gaming, film, and design, influencing how audiences perceive and interact with digital content. Think about everything made of molecules and atoms, and having hard underlying structures and chemical properties in chemistry and physics. These things are solid, and they're the obvious and direct for the computer and basic systems and devices to represent to our eyes and for our minds to perceive. So, the difference between polygonal geometry and 3D geometry, or excuse me, CAD geometry, if I can read. Polygonal geometry consists of vertices, edges, and faces. Vertices, singular being vertex, representing objects in a way that is suitable for visual effects and animations. This approach emphasizes aesthetic qualities and is prevalent in industries like gaming and film. CAD geometry, on the other hand, utilizes mathematical representations to create precise models for engineering purposes. It focuses on exact measurement and specifications, making it essential for architecture, engineering, and manufacturing sectors. Think about the human body and the smaller subsystems that make up the larger systems in the body, in the form of polygonal geometry. There's smaller vertices that make up the larger faces, and there's groups of vertices that make up objects that exist inside of a larger object grouping. CAD, on the other hand, think of things like the algorithm of pi to determine the dimensions of a circle, Pythagorean's theorem to determine the 90-degree angle, finding triangles, the circumference of a circle. Things like this are sort of a smart geometry is generated for CAD geometry. That's about as far as I can go because I was not professionally trained in CAD. Software that exists. These are the three main ones, but it is 2025 and there's a whole lot more. I'm thinking of Mudbox, Cinema 4D, but these are the three main ones. So Blender is the open source powerhouse. It is a powerful open source software that supports the entire 3D pipeline, including modeling, rendering, animation, simulation. Its active community contributes to a wealth of plugins and tutorials. There's a whole lot more than just these, but that's the ones that I've listed. Autodesk Maya is the industry standard. Autodesk Maya is widely recognized in the industry for its advanced tools and flexibility, making it ideal for character animation and visual effects. It caters to both beginners and professionals with its robust features. 3ds Max, user-friendly interface. 3ds Max is known for its user-friendly interface and is tailored for architectural visualization and game design. It offers powerful modeling tools and a variety of rendering options that enhance the creative process. Alright, so career opportunities as a 3D artist or in 3D art. So the first one being animation. 3D artists can work in animation studios, creating characters and scenes for film and television shows. Game design. The game industry employs 3D artists to create environments, characters, interactive elements, and video games. I want to say level designers too, although they're typically taking pre-made assets and placing them. Architectural visualization. This involves creating realistic 3D models of buildings and spaces, often used for architects and real estate developers. I want to say this is predominantly going to use CAD geometry, SketchUp and such. Product design uses 3D modeling to prototype and visualize products before production, ensuring functionality and aesthetics. This is where you're going to see a lot of 3D printing. Before, I'd heard about 3D printing in the past, but it was not accessible to the open public. You had expensive, large equipment that could do that thing. From what I'm told, now people can buy 3D printers in their homes, and they're quite a bit easier to use than they used to be. And so you can buy your own material to print stuff, and the software being much more accessible, such as Blender being free, as well as SketchUp too. I think there's a free version. You can create. There's a lot more people that can get into the product design space than there used to be. So that's it, guys. This is the basic fundamentals of 3D.